Missy here. I'm at home recording, so you might hear some background noises. Maybe we'll have some guest visitors, who knows. I'm going to start today just by going over using the TI-84 to graph because not everybody was in class today. And so I want to make sure everyone gets a chance to kind of see this. If you want to fast forward to the homework, feel free to do so. So I'm going to go to y equals, and I'm going to enter my graphs, my inequalities here. Now remember that to do this before you put them in here, you need to put them into y equals form because all of these already have the y equals here. So this has to be in slope-intercept form. So y equals, and then you're filling in the rest of that, okay? So in our example, we're doing y equals 2x. Let me not put that in here, and let me put that in here. 2x, there we go, plus 1. And it is going to be less than. So we are going to change the equal sign here. No, I didn't mean to do that. Okay. Let's see if it'll let us do it. This might be a bad example in this calculator, actually. It doesn't look like I can actually change that here. Okay, well, on your actual calculator, you will change it on the left side of the y sub 1. This isn't a real TI-83, so it's not really working the way that I want it to. Oh, there we go. Yay, I did it. Okay. All right. So you'll go down and you'll change this to, because it is less than or equal to, we're changing it to the triangle that's on the bottom. So this one right here. It looks kind of like a less than sign. That's what it is though. That's the less than sign. So we're going to say okay. And then we're going to go ahead and enter our next equation. So our next equation is negative 2x minus 2. All right. And then I'm going to go all the way over and hit enter and change this to greater than, which is going to be, I went past it. There we go. The upwards triangle. So the triangle that looks kind of like a greater than sign, right? Like, that's a greater than sign, okay, is going to be like this. And then we're going to press graph. So here you can see that we can see one part of our graph. It looks like we can't see the other equation, so maybe we need to back out a little or change our window just a tiny bit. Let me go ahead and just check to make sure. There we go. No, I don't have either of my graphs. Let's try again. There we go. Okay. I was like, one of them's missing. Here we go. So then you'll get a graph that looks like this, right? And so you can see this blue, all of this is the blue shaded area, and all of this is the red shaded area. We'll go over a little bit more analyzing these graphs, but that's ultimately how you put inequalities. Now, do note that in the inequalities in the calculator, there's no less than and equal to or greater than or equal to. You just have to know for yourself whether that should be a dotted or solid line based on the fact that this is less than and greater than. It would just be a dotted line. We can't do that on the calculator, so that's something you have to remember to interpret, okay? But again, that's how you do that. You go to the left of your y sub 1 and y sub 2's, change the line by hitting, you go over and press enter, and change the line to be the downward triangle for less than or the upward triangle for greater than. Okay? All right, so let's look down at our homework now that we've had that little review. All right, so this year students in the 9th grade are collecting dimes and quarters for a school fundraiser. They are trying to collect more money than the students who were in the 9th grade last year. So competition, of course. The students in 9th grade last year collected $143.88. So they want to collect more money than the children the year before. And if they want to collect more, not as much as, but more, then it should just be greater than. And again, they're collecting dimes and quarters. So we're looking at 0.25 times the number of quarters plus 0.1 times the number of dimes is greater than 143.88, and that is matched nicely with D. All right, C is wrong because it has the dimes with the value of the quarter. B is wrong because it has greater than or equal to. A also is greater than or equal to, and the dimes are mixed up with the wrong coefficient there. Number 2, a farmer is creating a budget for planting soybeans and wheat. Planting soybeans costs $200 per acre, and planting wheat costs $500 per acre. He wants to spend no more than $100,000 planting soybeans and wheat. Write an inequality. Okay, so we're going to have 500. Let's say we have 500. Oh, actually, no, let's start with 200 because that's written first. So 200 x, so we'll say soybeans are x, the acres of soybeans are x, and then wheat will be y, so 500 y, that's the wheat, and he wants to send no more, so less than or equal to $100,000. So that x represents acres of wheat, or sorry, acres of soybean, and the y represents acres of wheat. So it says name one solution to the inequality and explain what it represents in that situation. So what is one thing that would work in this inequality? Well, let's say that I have 10 acres of soybeans. If I had 10 acres of soybeans, then we would have 200 times 10 is 2,000. 100,000 minus 2,000 gives me 98,000 divided by 500 gives me 196. So 10 comma 196 could be one solution, right? You can plug in pretty much any value for x and then see what you would get for y to see what works. Let's say I wanted only, let's try 20. Let's say I wanted 20 acres of soybeans. So we have 200 times 20, and that's 4,000. Then 100,000 minus 4,000 gives me 96,000 divided by 500 is 192. So here we have now 192. Okay, so you can come up with different solutions that would work, and that is the number of soybeans or number of acres of soybeans and wheat in which they are spending no more than $100,000. Now you could also say, for example, 1 and 1. If they only plant 1 acre of each, they're going to be definitely under $100,000. Maybe not maximizing their budget. All right, number 3. Elena is ordering dried chili peppers and corn husks for her cooking class. Chili peppers cost $16.95 per pound and corn costs $6.49 per pound. All right, so notice chilies are X, corn husks are Y. All right, that's important. So chili peppers are going to be $16.95 X plus $6.49 Y. And she spends less than 50 on this chili peppers and corn husk situation. So we wrote the inequality there, $16.95 times the number of pounds of chili peppers, and then $6.49 for the number of pounds of corn husks. It says, can Elena purchase 2 pounds of chili peppers and 4 pounds of corn husks and spend less than $50? Explain your reasoning. So let's look at our graph. If she spends 2 pounds of chili peppers and 4 pounds of corn husks, that would be here, which is outside of our graph. So no, because 2 comma 4 is outside the shaded area, the shaded solutions area. Then it says, can Elena purchase 1.5 pounds of chili peppers? So 1.5 would be about here. And then 3 pounds of corn husks. So 3 would be right here. That is in the blue zone. So yes, I just dropped my phone. Yes, because it is in the shaded area. Another way that you could prove this is you can go ahead and plug that in. If we had 16, that's not a 6, that's a 9, got ahead of myself. 16.95 times 1.5 plus 6.49 times 3, is that less than 50? Well, let's check that out. So we get 16.95 times 1.5 plus 6.49 times 3 equals 4489. That is less than 50, so it works. So that's another way that you can demonstrate it, is by showing me your work. All right, number 4 says which inequality is represented by the graph. So we need to decide which of these graphs is represented here. Now, note that the blue area, 0, 0 is a valid point. So I should be able to plug in 0, 0 to this equation for it to work. And if I do that, then I know it works. So 0 minus 0 is greater than 12? No. 0 minus 0 is less than 12? Yes. 0 minus 0 is less than 12. 0 plus 0 is greater than 12? No. 0 plus 0 is less than 12? Yes. So technically these two options in terms of picking a point work. But now we need to determine something about the slope here. So let's put this into slope-intercept form. This would be 4x minus 2y is less than 12. And if I subtract 4x from both sides, I automatically see I'm going to have a positive slope here. So this is going to be negative 2y is less than negative 4x plus 12. We're going to divide both sides by negative 2. Since we are dividing both sides by a negative, the sign will flip and we'll have y is greater than positive 2x. A negative divided by a negative is a positive. Positive 12 divided by negative 2 gives me negative 6. So that's a y-intercept of negative 6 and a positive slope going up 2 over 1. So B is our best answer, and that eliminates D as our answer option. Now, just looking at D, I can tell that we would have a negative slope, and this has a positive slope. So that also helps me, right? If I subtract 4x from both sides and then divide by 2, I'm going to have a negative slope, right? Negative 4x plus 12. If I divide both sides by 2, right, you can see that this will end up being negative, and so we know that D is not an answer option. Number 5, Elena is solving the system of equations. She multiplies the second equation by 2 and then subtracts the resulting equation from the first. To her surprise, she gets the equation 0 equals 0. Why is that? So why does she get this result? If you need to, you can try graphing. So when I multiply this by 2, I'm going to get 10x minus 6y equals 16. Well, that is the same equation as this one, and so there are infinite solutions. If you were to go ahead and graph these, you would get that they are the exact same line, and looks like this would be a positive slope, so they'll be the exact same line, right? And that means that there is infinite solutions because one line is on top of the other. They have the same number of many solutions. That is a terrible infinity sign. Okay, that's a little bit better. All right, number 6. Jada has a sleeping bag rated for 30 degrees Fahrenheit. This means that if the temperature outside is at least 30 degrees Fahrenheit, she will be able to stay warm in her sleeping bag. Write an inequality that represents the outdoor temperature at which Jada will be able to stay warm. So temperature has to be greater than or equal to 30 degrees. Write an inequality that represents the outdoor temperature at which a thicker or warmer sleeping bag would be needed to keep Jada warm. So if T is less than 30, she would need to have a different sleeping bag. I'm not saying less than or equal to, because less than or equal to is included in this inequality, where if it's at least 30 degrees outside, it should be fine. But if it's any less than 30 degrees, then she's going to be cold. All right, number 7 says, what is the solution to this inequality? So in order to do this, I need to use my distributive property and simplify things first. So let's do that. 6x minus 20 is greater than 6 minus 3x. So I'm distributing that 3 right through here, plus 6x minus 2. So 6x minus 20 is greater than, let's combine like terms. I can combine negative 3x and positive 6x to be positive 3x. And then this is a positive 6 and a negative 2, which is positive 4. Now I want to move my x's so that they are all on the same side. So get 3x minus 20 is greater than, this cancels out 4. Add 20 to both sides. We'll get 3x is greater than 24. X then is greater than 8. So our solution set is x is greater than 8. Number 8, here is a graph of the equation. Are the points 1.5 comma negative 4 and 4 comma negative 4 solutions to the equation? Explain how you know. All right, so 1.5, so 1 is here, so 1.5 would be here. Negative 4 going down here, that is on the line. And if we were to plug it in and say 2 times 1.5 is 3 minus negative 4 times 3 is negative 12 equals 15. Yes, that works out. So we see it is a solution on the line. So yes for 1.5 comma negative 4. And then 4 comma negative 4 would be here. And that is not on the line, so no, it is not on the line. Then it says check and see if each of these points is a solution to the inequality. So 0 to this being less than 15. So I plug in 0, 5, negative 5. I would have 0 minus 3 times negative 5 is less than 15. That equals 15, so that is not true. So 0 comma negative 5 is not a solution. 4 comma negative 2 is 4 times 2 is 8, minus 3 times negative 2 is actually going to be 8 plus 6, which is 14. So 4 comma negative 2, which is on that side of the line, does work. That's a check. That works. So this one works. 2 comma negative 4. So 2 times 2 is 4 minus 3 times negative 4 is going to be 12, positive 12, so 16. So 16 is not less than 15, so this one does not work. So 2 comma negative 4, which is this one down here, does not work. And then 5 comma negative 1. 5 times 2 is 10, minus 3 times negative 1 is going to be 13, is less than 15. Check, that does work. So 5 comma negative 1, which is here, is a check. That helps me to know then that I'm going to shade this side of the line. There we go. All right, so shade this side to the inequality. C graph, we did that. Are the points on the line included in the solution region? Explain how you know. So the answer is no, because this is a less than situation and the points on the line are equal to 15. All right, number 9, a store sells notepads in packages of 24 and packages of 6. The organizers of a conference need to prepare at least 200